Ma'am calls them like a certain graph, a something graphs. Does anybody remember? You can unmute if you'd like. That's it. Katleho, lovely. Yes, we call them the mother graphs, right? Because they are the graphs of just sine x and just cos x and just tan x. And we look at them from the perspective of where sine of 0 is, sine of 0 degrees, sine of 90 degrees, sine of 180 degrees, sine of 270 degrees, and sine of 360 degrees, because that's a full revolution, right? And that works for sine and cos. But remember, for tan, our graph repeats itself after every 180. So we're going to halve all of those. 0, 45, 90 degrees, 135 degrees, and 180 degrees. So we can see. But we know that there's going to be a problem here at 90 degrees. Do we remember what that issue is? And we call it something very specific. Does anyone remember that dotted line that we're not allowed to cross when it comes to our tan graph? Do we remember what it's called?
Is that an amplitude?
Not the amplitude.
Asymptote.
That's the one. Yes. Lovely. Lovely, Mandisa. Well done. Yes, it's the asymptote. Right. The asymptote is the point of the graph where we would get an undefined function or a non-real function, because our graphs are only defined in real numbers, right? So if we look down here, we need to remember the period and the amplitude of each of our graphs. Do we remember what the period of a sine graph is? Anybody remember?
Ma'am, is not 180.
What is the period? Let's start there. What does the period actually show us?
How long it takes my graph to make a full wave?
Correct. How many degrees does it take my graph to make a full wave? How many degrees are we looking at there?
360 degrees.
Beautiful. Nicely done. Okay, so the period of my sine graph is going to be 360 degrees. What about my cos graph? How long does it take my cos graph to get from 1, come all the way down, come all the way back, and back up to 1?
360 degrees.
100%. Okay, 360. And the period of my tan graph, it repeats itself every? How many?
One time. Once.
After how many degrees?
180 degrees.
That's it. And I heard you both. Well done. All right, let's talk about amplitude. Do you remember what our amplitude is? We said that amplitude is the middle line.
How far up from the graph?
Correct. From the origin of my graph. So from that line where my graph creates an axis of symmetry. Right. So if we look at our amplitude of our mother graph, what is the amplitude here? How far up do we go from here to there? How far is that?
1.
It's 1. Well done, my darling. Good. That's 1. Same with this one. How far do we go from here to there for my cos graph?
1.
That's 1. Lovely. And what about the amplitude of my tan graph? Or let me ask this rather. Does my tan graph have an amplitude?
No.
No, it doesn't. Right. There's no point where my graph comes back down and then goes through. Right. So there's no distance, because my graph will keep going forever and ever up in that direction. Right. Like up, 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 and down, 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 down. It will just keep going. So that tells me that my tan graph has no amplitude, none at all. Okay. No amplitude at all. So that's what we learned about on, I almost said on Saturday, on Monday. That's what we learned about on Monday. I just need to figure out how to let all of these people in. Oh, there it is. Okay, Tabo's just joined us. All right, so we're going to be looking at a couple of transformations of this tan graph, or all 3 graphs from our mother graph. And the question that I want us to keep in mind as we're going, right, to each of these is what has happened to my mother graph. So all the transformations that we're looking at, we're going to look at how do they affect my mother graph. Okay, so that's the big question today. So we're going to look at the mother graph, and then we're going to look at a non-spelling graph, PH graph. Okay, we're going to look at the mother graph, and we're going to compare the graph that we have on the screen to what we are seeing. Okay, all right, so we're going to start with something a little simple. Let's start with f of x is equal to sine of 2x. Now, our mother graph says f of x is equal to sine x, right? F of x is equal to sine x. And I'm just going to color code these. I will draw the graph of f of x is equal to sine x, or sine 2x, in purple. And then let me change this to g of x. So we're not drawing the same graph with two different answers. Okay, and then I'll draw the other one in blue. I'll draw the mother graph in blue. Okay, I'm going to start with the mother graph because we already know what it looks like, right? So the mother graph will go straight through the origin, and then it will go up to 1. I'm going to put 1 all the way up here. Okay, there's 1. So it'll go all the way up to 1 at 90 degrees. There. At 180 degrees, it will give us 0. And then it'll go to 270 degrees. It will give us -1. So right there. And then at 360 degrees, it will give us 0 again. All right. So I'm going to draw this. Okay, and again, guys, I'm not an art teacher. I'm a maths teacher. Don't judge my drawing. Yeah, there we go. I think it looks decent. It looks kind of okay. All right, so this is our mother graph. We're going to draw the graph of sine 2x next to our mother graph, and we're going to compare what's happened between the two. Okay, so here's what we're going to do. We're going to use the exact same prompts. So calculators at the ready, guys. Okay, calculators at the ready. So we're going to have f of x is equal to sine of 2 times, normally we would start at 2 times 0 degrees. So I want you guys to put in your calculator, sine of 2 times 0. And obviously, I think the answer is still going to give us 0. But let me know, what does it give us? Sine of 2 times 0? Do we still get 0? Anybody got 0 for me? I know the answer is supposed to be 0. Yes, I know for a fact. Good. Yes, Abulele, we're supposed to get 0. Okay. It was kind of a trick question. We're supposed to get 0, right? Okay. Now, here's what we're going to do. Our next prompt would be at 90 degrees. I want you to, again, go to f of 90 degrees is equal to sine of 2 times 90. Sine of 2 times 90. Someone else can do f of 180 degrees for us. Is equal to sine of 2 times 180. Okay. Okay, f of 270. Okay, sine of 2 times 270. And I'm sure somebody's going to pick up on the fact that something is wrong with Mem's graph. I want somebody to tell me exactly what we figure out as we're going. Like, ma'am, something about your graph feels a little bit off. Has anybody picked up on it yet?
Ma'am,
Yes.
I don't know if it's because all the answers have +2 in the... No, I don't think that's it. Never mind.
But what answer are you getting everywhere?
0, eh?
Yes, correct. So we're going to get 0 everywhere, right? which is kind of weird. Okay, so that means that this new graph at 90 degrees is at 0. At 180 is also at 0. At 270 is also at 0. And at 360 is also at 0. Now, this is problematic, right? In that this is still the sign of, it's still the graph of sine, right? We should still be getting a graph. So instead of doing 90, 180, 270, I want to see what did we miss in between here. Let's see what we've missed in between here. So what we can do is let's try sine of 45. So f of 45 degrees, we're going to then have sine of 2 times 45 degrees, right? So we can see what's happening at the halfway mark over here, 45 degrees. Then we're going to choose the midpoint between 90 and 180. That's going to be at 135 degrees. Let's go look at what's happening there. Between 180 and 270, that is at 225, I believe. 225. And on this side, 270, we're going to look between 270 and 360. We can look at 315. At 315. All right, let's see what we get there. You can pop your answers in the chat if you want, or you can even unmute. I'm so happy for us to unmute today, guys, and just shout out your answers whenever you're ready. Okay, and let's see what our graph gives us at those points in between. Anybody got an answer for me?
Ma'am,
Yes.
for the g of x,
Yes.
0 is 0 degrees.
Mm-hmm.
For 90 is 1.
Good. It gives us 1.
For 180 is 0.
Okay, so for... Oh, yes.
180.
Oh, that's for g of x, my darling. We're not doing g of x. We're doing f of x. So we're doing this one. Oh, I should move it over to the side. We're doing f of x. Remember, g of x is the mother graph. That's the blue graph. So the graph that we're trying to figure out now is this one, the f of x graph.
Ma'am, you're getting 0 all over.
Yes, correct. Okay, so that's why I'm saying, Briganyo, I need you to check for me sine of 45. So use 45 in there. So you're going to go to your calculator and you're going to type in sine of 2 times 45 degrees. Okay, and then sine of 2 times 130 or 90 degrees. Oh, we know that's already 0. So 2 times 135 degrees to see what happens. Okay, yes, Oko. I can see your hand is up, my darling. You
For
can unmute.
45, we get you 1.
Yes, absolutely. Oko, was
Hi.
that? Yes, my darling.
For sine of 45 times 2, I got 0. And then for the 135, I got -1. For 225, I got 1. And for 315, I got -1.
Beautiful. That's correct. All of those things are 100% spot on. Wikanya, did you get something similar?
Yes, ma'am.
Yes, lovely. Okay, let's see what's happened here. Okay, let's see what's happened. So I'm going to go up all the way to 1, come down. Remember, at sine of 90, we got 0. So that must go through there. At sine of 135, through there. Let's go through there. There, through 0 again. And please do not draw like Teacher Coco, because clearly, wow, looks like a stock exchange graph. It's not. I promise it's actually a sine graph. I'll try again. Okay. Oh, guys, I should really start investing in learning how to use those graphing calculators online, like GeoGebra or something, because, oh, my drawings are terrible. Okay, cool. So let's compare what we are seeing here, right? So the sign of, or the graph of g of x, which is just the normal mother graph. Remember, this is the mother graph, right? Gives us one graph in 360 degrees. The graph of f of x is equal to sine 2x. How many graphs did that give us? How many graphs are we looking at? The purple graphs. I know my drawing isn't that great, but I'm pretty sure we can still tell how many graphs. Remember, one graph, guys, has to go up and then down and then back to the center. And then another one up, down, back to the center. How many graphs do we have here?
One.
Ooh, look at the purple one. Okay, there's one. And it stops there. And then another one. How many graphs did we have there?
2.
We have 2 graphs, right? So if we think about what this actually tells us, this part over here tells us how many graphs I can fit in 360 degrees. Let's just look at this in a little bit more detail. If I go to my mother graph over here, this is g of x is equal to sine of 1x. You see that? It's just, x is just 1x. So in the mother graph, how many graphs did we fit in 360 degrees? We fit one of them. One. It went up and then down and then back to the center again, right? But in this graph where we've added a 2, right, there is now one extra graph in it. So if I had a graph h of x is equal to sine of 3x, right? How many graphs would I be able to fit in 360 here?
3.
3 graphs, right? But then this will also affect my period, would it not?
Yes.
Affect my period, right? Because my period of my mother graph, the period is 360 degrees, because that's how long it takes to make one full wave, right? If we look at this graph here of f of x, right? How many degrees did it take us to make one full wave?
360.
No, not this one, that one, my darling. Look at the purple graph. How long did it take us to go up and then down and then back to the middle again? Here, this is where my 2 graphs cut in 2. Do you see that? So there's the first purple graph and there's the second purple graph. How long did it take us to get from there?
180 degrees.
It is 180 degrees, right? So the period of my graph will change because of whatever's happening in here. Okay, my period will be 180 degrees. I just want to double check with everyone. You can use your reactions. I like the reactions on this class. Just give me a thumbs up if you're understanding what ma'am is saying. Thumbs down if you'd like me to explain again, because I know it is kind of like a complicated idea. Okay, lovely. Okay, awesome stuff. Okay, so here's what we're going to take away from this. I'm going to move up a little bit more, right? We know that if we look at what ma'am has got over here, this b value, what did we say this b value affects? We've just looked at it. The what? The word starts with a p. It affects the
Period.
Beautiful. This value affects the period. It affects how many graphs we can fit in 360 degrees. Okay, that's the first thing. Let's go ahead and look at what the A and the Q and all of this other stuff will do. Right, let's look at the next graph. Okay, all right, we're going to skip that one for now. Let me see. Okay, no, we're going to do this one. We're definitely going to do this one. All right. Okay, so we're going to do the exact same thing we did with the other graphs, right? We're going to, because we know that our mother graph, and I'll call it g of x, our g of x is equal to just cos x, right? I know that my cos x graph will start at 1. Let me just see if I can get this aligned. Otherwise, it's going to bother me. Okay, there we go. So my cos x graph, or my mother graph, will start at 1 and then go all the way down to -1 on this side, right? Shall I draw the mother graph in in orange. Yeah, I can draw it in orange. Okay, so for my mother graph, cos of 0 degrees will give me 1. Cos of 90 degrees gives us 0. Cos of 180 degrees gives us -1. Okay, sorry, I'm hearing something and I just need to check to see that I didn't miss anything. Just want to make sure. Okay, everything's fine. All right, and then cos of 270, cos of 270, and then cos of 360, right? Cos of 270 is equal to 0 again, and cos of 360 is 1 again. So if we draw the mother graph, it'll look like that. It'll look like that. Okay. Now, we're going to do the same thing over here for cos of half x. So this is our mother graph. The orange one is the mother graph. Let's see how this changes from what we have on our mother graph. So again, guys, we're going to use 90, 180, 270, and 360, right? But this time you just need to go cos of half times 90. Cos of, oh, did I forget 0? Sorry, guys. I need to put 0 in there as well. Okay. 0 degrees. So let's start at 0 whenever you're ready, guys. I think I'll draw this one in red. Okay, whenever you're ready, just shout your answers and I will put your answers on the screen. Okay. So if you get cos of 0, tell me the answer and ma'am will put it on the screen.
Cos of 0 is 1.
Good. Cos of 0 is 1. Good. Let's keep going. What about cos of 90? Remember, you need to put in cos of half times 90. So cos of a half times 90 degrees. It should give you something ugly. So it should actually give you like a number with a square root in it. So I'm going to need you guys, I'm going to ask you guys to click the SD button for me, please.
Ma'am, is it 0,
Cos of
71?
It is 0,
71.
okay, 0,
Rounded up.
okay, so it's going to sit somewhere like there, I think. 0.71 would be there somewhere. Okay, I'm spitballing. It would be closer to 1, not closer to 0. Oh, but this is 0.5, so it would be closer to that. So it would be somewhere there. Okay, there we go. All right, let's do cos of 180. Let's see what that gives us.
Zero.
Good, it gives us 0, lovely. So at 180, we will get to 0. Let's go to 270. I'm going to guess it should be negative 0.71. Like,
Yeah.
am I correct?
Yes.
Lovely, lovely, lovely. Hello, Sia. Lovely to hear your voice. Okay, and then the last one
-1.
is -1. All right, so let's see what's actually happened here. Okay, there's my graph. Oh, Lord. Okay, I'm going to try that again. Let me get it at an angle. Make sure I do this correctly. Hey, guys, it's not looking good, hey? It's not looking good. Whew. Okay, we're going to cheat a little bit. Sorry, guys.
Ma'am,
Yes.
why is it going downwards?
That's a good question. Why is it going downwards? Okay.
Like, does it eventually go up?
let's see if it does. Okay, so now at the moment, we've only got a graph that goes down, right? Maybe let's try the numbers that come after. So we've got 90, 180, 270, 360. Maybe let's try 450. Let's add 90. Let's try 450. If we take cos of 450, remember we're going to get half times 450. Okay, then we can try 450 plus another 90 would give us 540 degrees. And then 540 plus another 90 would give us 640 and then 720. Have we figured it out yet? Anybody seeing it yet? Okay, does anybody have an answer for me at 450? Let's try 540. Let's go to 630 as well. And then let's go to 720. All right, what are we finding, peeps? Let's look here. At cos of 450, what answer am I getting?
Negative 0.71.
It's negative 0.71 again. And then at cos of 540, I'm getting, I should get 0, I believe. Okay, at 630, I'm going to get positive 0.71 again. And at 720, I should get 1. Okay, and this checks out, guys. And I'm going to explain why. Do you see that it takes us twice as long to finish the graph? Are you guys seeing it? It's taken us twice as long from 0 all the way till 720 to finish just one graph. Just one graph, right? And we said that sorry, Oko, I'm going to take your question in just a second. Right. We said that this part over here, the part right in the middle, tells us how many graphs we can fit into 360. And if we look at what's happened over here at 360, here, that was the 360 mark. How much of a graph had we fit into that space? It was
Double.
Not double.
Double. Oh, half.
It's half, yes, correct, Oko. It's half the graph. And that checks out because our equation here says that our graph is half of the mother graph. And that's exactly what we got. We got half of the mother graph. Okay, thumbs up. Is everybody okay with that idea? Yes, lovely. Okay, hello. I know it's Desmarie, but I love the name Desdemona. It's so beautiful. Okay. I do, but hi, Desmarie. I can see you giving me a thumbs down. I don't know where I've lost you, my darling, but I'm happy for you. Oh, you don't know what's happening. Okay, that's fine, my darling. Okay, I'm going to explain as we go along. But remember, Desmarie, from what we learned on Monday, right? The one question we're going to be answering in this entire lesson is what has happened to the mother graph. And remember, we spoke about the mother graphs here. So I'm going to continue drawing the mother graphs as we go along. And all we need to do is compare the mother graph to the new graph so we can see what's happened. Okay, that's all that we're going to do here. And we're going to figure out how all of these affect the other thing. All right, so here's the next thing that we're going to do. Let me use a different color. Let's use blue. Okay, we're going to map out this graph of sine. Again, I'm going to remind you guys, the mother graph of sine starts at 0 degrees, goes all the way up to 1, comes down, goes all the way down to -1, and then comes back up. This is at 360 degrees. That point at -1 is at 270 degrees. That point is at 180. That point is at 90 degrees. Okay, so we're going to plot again, guys, same things. We're going to use 90 degrees and we're going to, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. And I promise, guys, this one is actually going to give us a graph when we put those in. Okay, so whenever you're ready, you can just unmute, shout out the answer for me. Tell me, ma'am, for 0 degrees, we're at this. And I'll draw this one in blue, and we'll be able to compare. Okay, whenever you're ready, guys. Okay, so I'm just going to remind everybody, we're just going to put into our calculator 2 sine of 0 degrees, and then we're going to put in 2 sine of 90 degrees, and so on and so forth. So just 2 sine of that angle, 2 sine of that one, 2 sine of that one, 2 sine of that one, 2 sine of that one. So 2 sine of each of them. And then tell me what we get. Okay. Okay, anyone got answers for me?
For 0, the answer is 0.
Good, it's 0, lovely. Okay, this is the 1 mark. It's 1,
For 90,
90.
for 90, it's 2.
Good, for 90, it's at 2. We'll just say that 2 is over there. Let me actually stretch this one a little bit. Yeah. I'll just back down. Good. At 90 degrees, we are at 2.
At 180, it's 0.
Good. All right.
At 270, it's -2.
Good. -2. Oh, that's not the place down there. Yep.
And at 360, it's 0.
It's 0. Lovely. I just need to double check before we move on. I just need to check. Am I speaking to Sia or am I speaking to Abulele? Who am I speaking to?
Sia.
Is it Sia? Okay. Oh, I see your surname on the screen, not your actual name. So I was like, oh, what's going on? Okay. So now if we go all the way up from there to there, and then we come all the way back down over there. Who wants to describe for me exactly what's happened to our graph here when we add this 2 on the outside there?
The amplitude doubled.
Correct. The amplitude doubles. Well done, Oko. We can just say like it's a stretch, right? So because we put a 2 there, right, the amplitude has gone from 1 to 2, right? Because from the middle point all the way to how far up it goes from 0 to 2. So our amplitude goes up to 2. So we know that this A in front over here, in fact, it's the A of all of them. Okay, that one as well. And I forgot to highlight the B here. They all do the same thing. So this A over here affects the amplitude, and the B affects the period. Okay, now the next graph we're going to do is the graph of, let me pick a nice color. No, I want pink. I want to draw in pink. Okay, we're going to draw this graph, the graph of sine theta -3. And before I even continue, does anybody want to venture a guess as to how this is going to affect our graph? Just think about functions in general. How is this actually going to shift our graph? Or do we want to compare it to the mother graph first? Okay, we've already got the mother graph. Remember, it's the one in black. So we can draw this new graph in pink. Okay, but I'm actually going to need another graph because this one is not going to do the things that we need. All right, I'm going to move everything over to the side. Otherwise, we're going to run out of space, guys. And I need space. Okay, and I'm going to try and be quick about it. Oh, this thing. Always doing the worst. Okay, and then just a quick 90 degrees. 180 degrees, 270, 360. I really need to just learn how to draw one of these once, and then we never have to do it again. Okay, 1 and -1. So the mother graph will go up to 1 at 90, come back down through 180, down to 270, and out on the other side, 360. Okay, so we're going to draw the graph of y is equal to sine theta minus 3. Okay, and we're going to draw it in pink. So we're going to use the exact same prompts, guys. We're going to use 0 degrees, 90 degrees, 180, 270, and 360, right? And we're just going to punch those in. We're just going to go sine 0 minus 3 into your calculator. Don't forget, your calculator, when you click sine, is going to go 0, it's going to go sine, and then it's going to open bracket. So you need to go sine 0, once it opens bracket, 0, close bracket, and then say minus 3. Okay, otherwise your calculator is going to give you a funky answer. It's going to say what you've said doesn't exist and shouldn't do that. So after the angle, after the theta angle, close, and then add minus 3. Okay, and then you can just shout your answers whenever you guys are ready. Okay. Whenever you're ready, just let me know what you got.
For 0, it's -3.
Good. So for sine of 0, we get -3. Oh,
and the sine of 90, it's -2.
Okay, -2, -3. Sine of 0 is -3. Sine of 90 is -2.
For 180, it's -3.
-3 again at 180.
At 270, it's -4.
At 270, it's -4. So down here.
And at 360, it's -3.
360 is -3. Oh, thank you, Sia. Doing lovely. Just doing the Lord's work. I love it. Okay. So if I draw this, what has happened to my mother graph, everyone? Look at the difference between that graph and my mother graph. They're exactly the same graph. Let's admit it. They're, well, not exactly the same because Teacher Coco's drawing isn't the best, but they are exactly the same graph, right? What's the difference that we are seeing here? What's happened to my mother graph? There's been a shift. What kind of shift are we looking at here, grade 10s? Is it a vertical shift? Is it a horizontal shift? What kind of shift are we looking at?
Vertical shift.
Good. Right. It's shifted my graph down by 3. We see that. Right. Where normally sine of 0 would have been 0, my sine of 0 gave me -3. So this whole graph is exactly the same. It's just that it's been moved down here. Right. It's been moved all the way here. So this value here at the end of my graph, that affects a vertical shift. So we know that this Q value over here, and I feel like I keep leaving tan out, but we're going to get to tan as well. Right. So this last part over here is a vertical shift. Okay. A vertical shift. Same with, we've got the same thing over here at tan. The only difference is that the amplitude of tan is never affected, right? That's why ma'am didn't put an A here. I didn't put an A there because tan doesn't have an amplitude. So only the sine graph and the cos graph will have an amplitude. Let me just ask this question. It's just a yes or no question, right? Is my amplitude or my period affected by the vertical shift? Yes or no?
No.
No, No, it's not. Because I still have an amplitude of 1, and my period is still 360, right? But we can't stop there. Let's quickly look at what happens when we put all of these things together so we can kind of rationalize where our answer needs to go. All right, so we're going to do C. I want everybody to help me out. We're going to do C. Okay, now I want you guys to draw this one all on your own. You're going to use those exact same prompts. Remember, what you're going to do is you're going to draw the mother graph, and on the mother graph, you're going to then draw this new graph, because then you can see what's actually changed from the mother graph to this one. Okay, just give me a thumbs up. Is everybody okay with the instruction? We are all doing C. I see a raised hand. I just want to see if this person has a question or if that was just you meant to say thumbs up. Okay, so we're doing C, guys. We are doing C. And so this is a cos graph. So first, you're going to draw your Cartesian plane. You're going to draw a very rough sketch of your cos graph, everywhere that your cos graph would turn and things like that. And then you're going to use these 5 degrees, these 5 points here. Okay, and then you're going to let me see. I don't know if we have any reactions in the messages. I don't think we do. So I'll just ask you guys to type done in the chat for me. Okay, can I give you guys about 5 minutes to try that? And then we'll look at what happens. Okay, when you're ready, guys. Just gonna set up quickly and then go fetch a jersey, because why is ma'am not wearing a jacket in this weather? Sorry guys, I'm just going to move it over here. That's the graph we're drawing. And then I'm going to include my new Cartesian plane. Oof, not that one. This one. Right, and then I'm quickly going to draw my mother graph. I'm going to start with my mother graph. Okay, so my mother graph would go from 1 to 90 degrees, 180 degrees, 270. I can actually space these out a little bit more. We have room. Let me make it a little bit bigger. I'm going to make them bigger. Okay. So we can see it better, especially with ma'am's terrible drawing. Two, 0, 90, 180, 270, and 360. All right, there we go. All right, please don't run away, peeps. I'm just gonna go fetch a jacket. I'm freezing. I can see Buikanyo's done. That's lovely. Oko's done as well. Lovely. Oh, Desmarie and Sia are done. Okay, I'm gonna give it one more minute and then we'll get started because I can see most people are done, which is lovely. Okay. Oh yeah, let me draw my mother graph quickly. Okay, so my mother graph would go from there down there. Oh, I forgot to put in my -1 and my -2. -2. From 180, it'll go through and then it'll come back up. And guys, again, hey, no Pablo Picasso, I teach maths. Really, guys, really, yeah. Okay, it'll be fine. Okay, a few more seconds for those of you still busy, and then we'll get started. All right, peeps, let's look at the answer that we got. Okay, so if I use the prompts that we had, 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees, right? I'm going to find that at cos of 0, I'm actually going to get -1, right? So my graph will be here at -1. Okay, guys, please correct me if I'm wrong. Okay, because I'm kind of doing this in my head as we go. All right. At cos of 90, I should get 1. Oh, did I mess it up? No, I didn't. What do I get at cos of 90, guys? Help me. My brain has... I get?
You get 1.
1.
Yes.
Cos of 90, we get 1. Okay, we get 1. Yes, okay. I'm not losing my mind. Good. At cos of 180, what do we get?
You get 3.
3. Okay, yeah, so I didn't lose my mind. I thought, I was like, Teacher Coco, did you do the right thing here? Yes, it's just the amplitude is a lot bigger. All right. At
1,
3, right? And that's exactly where I've put all my stuff. So we're going to remove those. Ooh, guys, I'm doing great. Wait for Teacher Coco to catch up. Clearly, I'm not awake yet. Let's see. There we go. All right. So for cos of 180, we get 3. You said, Sia, hey? We get 3. At 180, we get 3. And at 270, I'm going to guess we get 1.
1,
Good. And at 360, we should get?
-1.
Beautiful. -1. All right. Okay. So I'm going to try and draw. Guys, hey, I'm sorry, man. I'm sorry. All right, so this particular transformation has really, really like warped our graph, right? In that our amplitude is going to be something completely different, right? Our graph almost flipped upside, well, not almost, it did. It flipped upside down And what else has happened? Okay, let's talk about what has happened to our graph over here. We know that this negative flipped our graph upside down. Yes, is everybody with me there? This is a flip. Give me a thumbs up if you understand what I'm writing. It's flip, right? We've had a flip. Good. So that's flipped our graph. What has the 2 done to our graph? What has the 2 done to our graph?
Made it bigger.
Correct. It's made it bigger, or it's stretched it, right? It's stretched it in this direction, right? So it's stretched. So the 2 has given our graph a stretch, right? And remember, we said that this stretch is actually our amplitude. So our amplitude will change as well. So this is a stretch, right? And what did the +1 do? What has the +1 done? Hello, Didi Malo. I know you're a little late. It's okay, my darling. Okay, well, the lesson's actually over. I'm going to chat with you in just a second. Okay, the +1 it's lifted my graph. Guys, if we look at this graph specifically, do you see how our cos graph has exactly half the graph above the line and exactly half the graph below the line? But if you look at the purple graph that we just drew, instead of having half the graph above the line and half the graph below the line, the whole graph, it's like a third of the graph is above the line and the other quarter, or 3/4 of the graph is above and the other quarter is below, right? So this one has...
So, ma'am, would this graph be positive or negative?
It's definitely negative because it's flipped. Think about what my mother graph should look like. My mother graph started +1, and this one started at -1. So what has actually happened to my mother graph? It's been flipped. Do you see that?
Okay. Thank you.
Lovely, good question. Okay, so it's flipped my graph, and we said that that last part of my graph is a vertical shift. It's a vertical shift up and down. Okay, this is a vertical shift, and that's what we're looking at today. Okay, this is where we're going to stop for today. I know this is a lot of information to take in, and the technology also, guys, it's not helping. I don't know how I feel about Google Classroom. It's a conversation we must have later on. But thank you guys for joining me as always. I know for a fact that if you have joined us on Google Meets today, that means you are part of Google Classroom. So I'm about to set an assignment of the next quiz, or this week's quiz, for you. Okay, so you're going to find the quiz ready for you. It's on trigonometric functions, but it's on specifically the transformations that we did today. So things like the period, the amplitude, what has happened to the mother graph, explain. All right, so all that kind of stuff is what we're going to get today. So the big idea that we're looking at here is for you guys to answer the question, what happened to my mother graph? What happened to my mother graph? So that will then be able to tell you, because the amplitude of my mother graph should be 1. The period of my mother graph should be 360 or 180, depending on what it is. Okay, whether it's a sine graph or a tan graph or a cos graph. Okay,